about the amazing designs in all living creatures. Now, before I go into it, I'll just let you know that we are going to answer questions as they come in on the right side of your screen here, and I and one or more of my colleagues will be able to help answer them, but just a small request that the questions are dealing with the topic of my talk, because we have a great website, as I'll explain, where you can find answers for all sorts of different topics with 12,000 articles on the site. But a bit about where I'm coming from. I am a PhD scientist. I mean, there are plenty of people who say that there aren't any real scientists who believe the Bible, but there are actually plenty of us. And in fact, one place you can find them is our book called Busting Myths, which has interviews with 30 PhD scientists who are physicists, chemists, paleontologists, rocket scientists, even the inventor of MRI, all interviewed in this. And in fact, science grew out of a Christian worldview. The idea that we have a divine lawmaker who's a God of order, not the author of confusion. So science actually grew up in a Christian framework of the Middle Ages in Europe, where it was still born in places like ancient Greece and ancient China that lacked this idea of a divine lawmaker. I guess by now, you know, I'm not from this country, even though I became a citizen of this country last year. I originally come from this country, and I did move over here about 10 years ago. And one reason is we have two granddaughters who live in Florida. So instead of flying 9,000 miles, we only have to drive 500 miles to visit them. I'm also a retired chess master, something I used to do for a hobby, play blindfold, which is from memory. See, I'm playing here on the left side here, and I'm playing these 12 guys. This guy's making my moves for me and telling me what they're doing. And played some good people in my time. Another thing about me, I'm also ethnically Jewish. My name is the Hebrew word for Frenchman, which means I can tell Jewish jokes and French jokes and get away with it. But one thing to know, we have this website, as I mentioned before, where you can find all sorts of great stuff. And just in case you don't remember it, our website is creation.com. And one place you can get informed about what we have on our website, as well as creation speakers in your area. Once this illness pandemic has subsided, you can go to our free email newsletter. And in fact, this comes out every few days. We promise not to spam you or to give or sell your address to any third party. And in fact, you can sign up as we are going right now. Text your email and zip code to this number. And the site answers two basic questions. Is creation true, and does it matter? And we can see we have all sorts of classic articles in the archive, and it's updated every day with something new. Like we had an article on the coronaviruses and why God would create viruses. In fact, most viruses are good for us. But when it comes to design, one person to go to is the famous atheist from Oxford University, Richard Dawkins. Now, it's interesting, he admits here, biology is the study of complicated things that give the appearance of having been designed for a purpose. Now, Richard Dawkins, as an atheist, rejects the idea of a divine designer. He thinks that we all are rearranged pond scum and we got here by time and chance and natural selection. But it's interesting, the Apostle Paul also says the invisible things of him from the creation of the world are clearly seen, being understood with the things that are made, even as eternal power in Godhead, so they are without excuse. This must include Darwin and Dawkins. They are without excuse to deny a designer, a creator from what's been made. Okay, so how do we tell whether something's designed? Well, one way is to see it being made, but even if we haven't seen it being made, there are things we can look at. Like take this aeroplane. Now, we know it's designed, but how exactly do you know? Well, one thing you would look for, it has loads of correct components. But you realize it's made up totally of non-flying parts. I mean, the fuselage doesn't fly, the wing doesn't fly, the engine doesn't fly, the cockpit doesn't fly. So how do I ever get back to Australia? Use high-speed rail? No, the answer is they are organized correctly. And every time we see something that's been organized correctly, we know there's an organizer behind it. See, what's the alternative? I'll give you the evolutionary view of forming an aeroplane. See, evolution can be summarized by matter plus time plus energy produces organization. So now I'm going to test this with the production of an aeroplane. So we have matter in the form of a junkyard of aeroplane parts here. We have a tornado to provide the energy, and you can have as much time as you want. And eventually you're going to get an aeroplane. Well, how does this look? Maybe not so believable. Now, what if I told you instead that what I'm showing you here is the aeroplane being hit by the tornado and turning it into a junkyard? Does that sound more believable? Well, do you know why it sounds more believable? Well, the answer is very simple. There are many more ways of being a junkyard than being an aeroplane. So when you have time and energy, you go to the more probable state, which is a junkyard. And you can have as much time as you like, and it's going to still be a junkyard after all this is going on. And this is a very useful principle for all of you out here. I mean, tell me, do you have to tell your children to mess up their rooms? Well, the reason is there are many more ways of being messy than being tidy. So if you have your children who provide energy and the things in their room, it's going to produce a mess because there are many more ways of producing a mess. Simple. So if you want to have a tidy room, the kids are going to have intelligence and know-how to put things in the right place. Now compare this to living creatures. Well, living things are unique because they can make copies of themselves. Your children are sort of copies of you. Now, did you ever see a jet plane having a baby jet? It's not self-copying. And even the factory that built the jet doesn't have baby factories. A photocopier copies documents. It doesn't copy itself, but all living things basically copy themselves. And in fact, your body is composed of about 30 trillion human cells and about 40 trillion bacterial cells and about 400 trillion viruses. I bet you didn't know that, but it's true. And all those cells copy themselves. So we can't even make a machine that can copy itself, but every living thing is a self-copying machine, you might say. So there's no such thing as a simple cell. Every cell has to be enormously complicated to be able to copy itself, as well as to do things like diagnose and repair injuries to itself. Now, I'm going to do a little experiment here. Isn't science supposed to be about experimentation and repetition, observation, testing, all these things? So I'm going to test this idea of matter plus time plus energy produces organization. And this time it's with a frog in a blender. And I turn the switch on, I'm adding energy to the system. And what's the result? Well, it's a frog smoothie. Now, if I left this going for millions of years, you'd think a frog is ever going to hop out of this. Well, again, the reason it's not going to happen is there are many more ways of being a smoothie than being a frog. See what a useful principle this is. Now, another thing is you could actually can this frog smoothie and sterilize it and seal it, and it'll be safe to eat for many years. And not just frog smoothie, it applies to any canned food, canned sardines, canned Georgia peaches. The principle's the same. All the components of life are in the can. But you can apply whatever energy you like to the can. You can have as much time as you want, and I guarantee no living thing will ever form in there. And that's why you're not going to get food poisoning, because food poisoning comes from living creatures. Bacteria make poisons. But the thing is, as long as the can is sealed, no living thing will ever grow in there. And this is actually a real law of science called the law of biogenesis, which says that life comes only from life. It doesn't come from non-living chemicals. In fact, the only way you're going to get bacteria growing in the can is if the seal got broken and it was contaminated from outside, but it's not going to come from within. And this is also why antiseptic surgery works. This was discovered by a creationist called Joseph Lister. See, at one time, surgery was as dangerous as whatever condition it was treating because of the danger of infection. But Lister realized that the things were not being generated spontaneously. They had to have come in from outside to contaminate the wound, so he had an antiseptic spray to stop the germs getting in to the wound. And that has saved millions of lives in the last 100+ years. Now, just to give you a little idea of how complex even the simplest living things are, I'm going to go to this famous molecule called ATP. Now, don't worry too much about the chemistry. I'm a chemistry nerd. I'm a chemist by training. You don't have to be. But ATP is the energy currency of life. It's so important that your body makes its own weight in ATP every day and consumes it. So that's why you're not putting on weight. It's consumed as fast as you make it. The point is, cyanide kills you by stopping ATP production. So this is very, very important, this stuff. But now we know it's made by the tiniest motor in the universe.
This animated sequence shows the ATP synthase enzyme in operation. The animation is based on an incredible series of scientific discoveries. Only the colors show artistic license. ATP, or adenosine triphosphate, is the energy currency of the cell. ATP is produced by a tiny molecular rotary motor, rotating at up to 7,000 RPM. These are so small that 100,000 would fit side by side in a millimeter. A current of protons drives the motor, unlike man-made electric motors which use electrons. This portion of the enzyme is where adenosine diphosphate is combined with a phosphate ion in the presence of a catalyst to produce ATP, which is then released, making way for the next cycle. A top view of the enzyme shows the sequential operation. Almost every biochemical process in your body requires ATP. Such a nanomachine exhibits all the characteristics of super-intelligent design. ATP is vital for life, and many of these motors were needed before the first living cell could exist. An evolutionary impossibility.
I mean, think of motors in general. A motor is not going to work until all the components are together in the right position. You have to have something to rotate, something that's held in place, and some power source, as well as coordinating that power source so it's always turning in one direction. So your motor needs all these things working together. So the same applies to these biological motors, which are far tinier than anything we can make. Now, let's go back to the aeroplane again. Just think about yet another interesting issue, and this is the issue of information, the instruction manual. I mean, just think about the aeroplane again. What would really show design here is finding the instruction manual to build it. So not only the components and the organization, but the instructions to build it. And in fact, living things, we also have the instruction manual to build them. And this is the famous DNA molecule, which stands for definitely no accident. Well, it actually stands for deoxyribonucleic acid. Now, this is actually a chemical molecule which has a sequence of letters. In fact, I'll show you a little bit. It has 4 different letters. Called A, T, and G, and C. And the A always bonds with a T and the G with the C. So it means there's a way not only of having the instruction, but also copying them to the next generation, because A will always go with T, etc. Okay? So in fact, when it comes to your own children, they didn't get their mother's eyes or father's ears. It was the instructions on the DNA for mother's eyes and father's ears that got copied to the child. When fertilization happened, the scientific beginning of life is fertilization or conception. This is not a religious claim, it's a scientific claim. That's when new life begins, and that's where the DNA from mother and father combine to produce the child. DNA, as I say, stands for deoxyribonucleic acid. Now, a bit of chemistry here is that DNA is quite a strong acid. It's a stronger acid than vinegar or lemon juice. And that actually is a good design feature because it means it has a negative charge inside your cell, and that provides an electric force field to protect it against certain attacking molecules that would otherwise break it apart. So that's one design feature of DNA, the fact that it is an acid. Now, how much DNA do you think we have to have? How much information does it store? Well, the simplest known creature that can copy itself is called a mycoplasma. Now, of course, viruses are in the news, but viruses don't really copy themselves. They had to hijack your cell's machinery and use the cell's copying machinery to make more of the viruses. They can't do it by themselves, and they're not really truly self-copying. The simplest self-copying thing is a mycoplasma. Now, this is probably too simple to survive. I think it's degenerative and something more complicated because it can't survive without being a parasite. So this mycoplasma has about 600 kilobytes of information on its DNA, but the information must be incredibly compressed because to try to model what happens when this creature divides in two, makes a copy of itself, it took over 100 computers running for 9 to 10 hours in parallel. So it gives you an idea there must be incredible data compression software even in the so-called simplest living creature. And DNA itself is the densest information storage system in the universe. I mean, you guys have computer hard drives and solid state drives. What are they, about this big? They store 1 or 2 terabytes maybe. But in the cell, a cubic millimeter of DNA would store 1,000 terabytes. So I think you can see that DNA Valley would leave Silicon Valley in the dust. We have nothing to compare with the information technology of all living creatures. Now, I'm going to show you a bit about DNA and show you it has multiple levels of information. Now, this clip comes from our DVD called Evolution's Achilles Heel. It's very well worth watching. It has study guide as well. Now, here we go. See, it's got the sequence of letters. That's the first thing. That's the one dimension. But then you have it's coiled up into certain patterns. That's called chromosomes in living creatures. And then you see how it's also positioned in the right place in the cell, as well as the right time of the cell. For instance, your eyes have all the information to build who you are, but you don't really want a bone popping out of your eye socket. Not going to happen because the bone information is switched off and only the eye information is expressed. So the cell in the eye has to have the eye information where it's accessible. The bone information can be buried deeply, but also we're very dynamic, so things change over time. So it's even got the code to change and to position the DNA in the right place in space and time. So there's some quite amazing programming in multiple dimensions. Now, I said also that DNA provides a way of copying the information to the next generation, but it doesn't do it by itself. It needs an enormous amount of help from lots of different machines. So I'm going to show you a very simplified program about how DNA is copied in living creatures.
Using computer animation based on molecular research, we are now able to see how DNA is actually copied in living cells. You are looking at an assembly line of amazing miniature biochemical machines that are pulling apart the DNA double helix and cranking out a copy of each strand. The DNA to be copied enters the production line from bottom left. The whirling blue molecular machine is called helicase. It spins the DNA as fast as a jet engine as it unwinds the double helix into 2 strands. One strand is copied continuously and can be seen spooling off to the right. Things are not so simple for the other strand because it must be copied backwards. It is drawn out repeatedly in loops and copied one section at a time. The end result is 2 new DNA molecules.
So this happens in even the simplest cell, but you see how complex the machinery is that's required to copy the DNA. Now, one problem for evolution, though, is that DNA has the instructions for its own copying machines, but you can't pass on those instructions unless you already have copying machines. Another thing is the copying machines must be incredibly accurate. You see, if you had only 100 letters to copy, only 1 in 100 of mistakes is allowed. If you had 1,000 letters, it's 1 in 1,000 accuracy. We have about 3 billion. So you imagine the accuracy that's needed to avoid passing on mistakes, because otherwise you get what's called error catastrophe. And this means you copy the instructions for the copying machines, you make a mistake. That means the next generation of copying machines is going to be less precise and therefore introduce even more mistakes when the next generation is copied. So the next machines are even worse, which do an even worse job of copying, which make an even worse job of the machine. So you see, it crashes to a halt really, really quickly. And also we can go back to Genesis 1, where it says that God created everything very good. And I think we can see from science that things had to start very good. They couldn't just start off being moderately good, because then that error catastrophe would break things down really quickly. So unless it started very good, as the Bible says, it couldn't start at all. So what we're seeing is what we see in nature as well as the Bible, that things started off very good, and now we've got things going downhill thanks to the fall. So things that started off good and they're going downhill. They didn't build up to very good. That's scientifically impossible, as I've just shown you. Now, another thing with DNA, think about, I've told you it's a coily sort of molecule. They call it a double helix. It's like a spiral staircase with the letters being like the steps on a spiral staircase. Now, think about this hugely long coiled molecule. Now, it's only a few atoms thick, but in fact, the DNA of each of your cells, any one of your cells, the DNA laid end to end would be about 2 meters, about 6 feet long, you see. So imagine very thin coiled things 6 feet long, and how tangled up that could get. I mean, think about people who are a bit older and remember when you had landlines with the coils. I'm sure you remember them being tangled up. Now, this would be a real problem with DNA. But DNA, in fact, it needs a whole lot of help to solve this problem. I'll show you what actually happens here.
Let's consider what happens as DNA unwinds during replication. As DNA unwinds, it acts like this rope when we pull apart its 2 strands. As you pull the strands apart, twisting tension builds up in the rest of the coiled portion. It is actually adding 1 twist to the remaining rope for each twist pulled out of it. At some point, you can't separate the strands anymore. The remaining rope is too tightly twisted. If you relax your tension on the rope, it will twist around itself in a supercoil. It is releasing tension. If you want to keep pulling the rope apart, you have to release the tension periodically, and one way to do this is to cut the rope and splice it back together. This problem has been best characterized in small circular DNAs. There are 2 methods of dealing with this problem in DNA. One cuts only 1 strand of the DNA double helix, and the other cuts both strands. Let's look at the first. Topoisomerase I enzymes cut a single strand of the double helix, pass the other strand through the cut, and reseal the break, relaxing the overwound molecule, which now has 1 fewer twist. Topoisomerase II enzymes do the same thing but with both strands of the double helix. Topoisomerase II cuts both strands of a double-stranded DNA and passes another double strand through the break and then reseals the break. So if a molecule of DNA is supercoiled, topoisomerase II can remove the supercoiling, 2 twists at a time, to yield a relaxed circle.
Some pretty amazing machines. Now, again, all living things have to have